Okay, so now what we're going to do is we're going to talk about exactly the details. We're going to talk about the details of how this reaction works. And it's important to note that in terms of mechanisms and in terms of what you're kind of expected to know, at this point we've really done, mechanisms for HBr addition, H2O addition, and methanol addition. And overall, these three reactions up top, they had very similar mechanisms. They all went through this carbocation intermediate. This is going to be your fourth mechanism that you'll have learned, and just like with these first three mechanisms, it's totally fair game after I give this to you for me to ask you this mechanism on a quiz or an exam. Okay, so let's start off with the alkene. So we said in the last video that the alkene is actually no longer going to be acting as a base, like the alkene acted like a base with the HBr, the water, and the methanol addition. So overall, the alkene was acting as a base in the initial step. So now we're going to have this alkene, the electrons now acting more as a nucleophile because, well, really at the end of the day, talking about it as a base just isn't really appropriate because it's not really taking a hydrogen from anything. Okay, so what we're going to do is we're going to still utilize these electrons, and they're still going to be doing some attacking. Okay, so if you think about this as a nucleophile, that means that if this is our nucleophilic molecule, our Br2 is going to end up being our electrophilic molecule. So we're going to be forming a new bond, either between carbon 2 and the bromine or carbon 1 and the bromine. And so after we form this new bond, this is where this mechanism deviates a little bit, which is that after one bromine is attacked, two separate things happen basically simultaneously. These two things are that this bromine to bromine bond gets cleaved, so this is happening, while at the same time the electrons from this bromine right here, so let's just color these guys red, these electrons now can either attack carbon 2 or carbon 1. So now let's just because it's prettier, we don't have to crisscross, I'm going to attack carbon 1. So these electrons red are attacking carbon 1. So now that we've designated the bromine attacking carbon 1 and forming a new bond to carbon 1, it's really obvious now that carbon 2 is going to be the one that's utilizing these blue electrons to make a new bond to bromine. And so actually go ahead and pause the video and see if you can predict the way that this molecule will look after all of this bond making and bond breaking. It might be a little bit of a challenge. Okay, so after we've done this bond make, bond break kind of interaction, the molecule that we're going to get is going to be similar to this. So overall, we know we're making a new bond between 2 and bromine, and we use the blue electrons for that. And we also know we're making a new bond between bromine and carbon 1. We use the red electrons for that. And so at the end of the day, we've made two bonds, and we've broken this old bromine to bromine bond. So that other bromine B, I guess, this is bromine A, bromine B is no longer there, and bromine A is left over. And so now what we need to do is we need to take into account the lone pairs on this bromine. So if we have 1, 2 here and 1, 2 here. So 1, 2, 3, 4. And what you'll find is if you do the valence, or the formal charge calculation on this bromine, it's going to be 7 minus 1, 2, 3, 4, 5, 6. So 7 minus 6 is going to yield a plus 1 charge. So just like with these top reactions where we made a charged intermediate, we're doing the same thing here where we're making a charged intermediate. This molecule has a very specific name as well. It's called the bromonium ion. So this is our bromonium ion, and at this point we're not quite done. So for all of these reactions, all of these mechanisms that we're doing, if you're ever doing a mechanism on your own and you find out that you have a charge left over on your molecule, that should be a pretty good indication that you're not done, that you need to do a little bit extra. So we never really get charged molecules as final products along the way. We always try to strive towards charge neutrality. So what we need to do here is consider charge conservation. So thinking about the overall charge on the left-hand side of the reaction versus the right, we have a disparity here. So we have a neutral versus a positive. And so the way we can make the right-hand side neutral again is to don't forget about that carbon B. So carbon B is over here. And now if we drew in all of the electrons for this other carbon right here, carbon B, this guy has 2, 4, 6, 8 electrons, so 7 minus 8 is going to be a negative. So this is going to be a negatively charged bromine. And so now if you look up top, we've got, bromine B versus bromine A. And really what we're going to do is, it's obvious at this point that we're attaching a new bromine to this molecule right here. So we're going to have bromine B attached to, one of these carbons right here. And the way that I've drawn it up top, I've got bromine B attached to carbon 2. So let's just go ahead and keep with that. And what I'll do now is we can utilize this molecule and this molecule, and let's try to give them names. Let's try to say electrophile and nucleophile. This molecule, or this bromine on the right, is looking pretty good as our nucleophile. And so this is our electrophile, this is our nucleophile. And so now we can have this nucleophile attack this electrophile. So let's try to zero in a little bit more and say nucleophilic position and not just nucleophilic molecule. So obviously this is easy because there's only one position here, that's the bromine. So it's doing the attacking. So it's very tempting at the very beginning to talk about where these electrons can attack. And it's very tempting to have them try to attack this bromine A right here. And so really, if you think about what that would mean, that really means that that's bromine B is attacking bromine A. And we're not only attacking it, but we're making a new bond between bromine B and bromine A. And if we look up at our final product up above, we know that obviously this bromine A is not attached to bromine B. So even though this is not a bad idea, we know, because we know the final outcome, this is not going to be our arrow or our electron push. So that's no good, so let's get rid of that. That's no longer a good possibility. So now if you look at this molecule, we see that, we have bromine B attached to carbon 2. So we've made a new bond between bromine B and carbon 2. And so now if we draw out all of our carbons now and give them names, this is 1, this is 2, and this is 3, it's obvious that, well, okay, if bromine B is making a new bond to carbon 2, we're going to attack carbon 2. So if we attack carbon 2, this is what it would look like. And at this point, it's very easy to make a mistake and just not move on from here. And the reason this would be bad if you stopped at this point is, well, one, we're kind of violating this mantra that we've been saying over and over again, which is if you make a bond, you have to break a bond. And so we've made a bond, but we really haven't broken a bond. Okay, so the bond that we're going to be breaking is that blue carbon 2 to bromine A bond. But if we didn't break that bond, one thing that we definitely would be violating is the octet rule, right? Because right now, this carbon 2 already has 4 bonds to it. And we said that carbon, can never really have more than 4 bonds. It would be breaking the octet rule, and it would become a Texas carbon. So let's go ahead and break that carbon 2 to bromine A bond. And so then let's draw out the final product. And so the final product, actually, I'm just going to be lazy and make this the final product. So this is our final product right there. So if you think about that bromine A, we said the bromine A is attached to carbon 1. So we've got all of our electrons taken care of. So now this is our final molecule, and this is going to be our vicinal dihalide. So it's very important to be able to recognize this mechanism is quite different than old mechanisms. We go through this bromonium ion, and this is a very important term to know. Bromonium ion, and it's overall a 2-step mechanism. First step has 1, 2, 3 arrows that basically happen simultaneously, and they can be a little confusing unless you color and or number. And then the second step is the destruction of this bromonium ion to give us the vicinal dihalide.